Hey guys, we need to be able to solve systems of equations, and in this lesson, we're going to talk about using substitution to solve systems. We know that we can solve systems of equations many different ways. We can graph them and see where they intersect. We can use substitution, which we're going to talk about right now, and you can also use elimination. Ready? Let's take a look together. So the directions say solve each system by substitution. Substitution is when one or both of the equations is already set equal to a variable. So or both of the equations is already y equals or x equals, and whatever that equation is set equal to, we substitute the value that, let's say, y is equal to into the other equation where we see y. Or if we see x equaling some expression, then that expression gets substituted in for x into the other equation. When we do that, we're only down to one variable in the equation. We're able to solve for that variable, and then we use that answer to plug in to solve for the other missing value. Let's take a look here together. So the first one, y equals negative 2x and y equals x plus 3. So both of these equations are set equal to y, which is fantastic. What this means is that the expression here of negative 2x, y equals negative 2x is going to get substituted in for y in the other equation. So when I take a look at that, this now becomes not y equals, but negative 2x equals x plus 3. What do I have on both sides? Variables or numbers. I have variables. I'm going to go ahead and get rid of the variable that's on the same side as my number. So I'm going to subtract x. Negative 2x minus x leaves me with negative 3x. My x's simplify out, equals 3. Negative 3x equals 3. I divide both sides by negative 3, and I end up with x equals negative 1. Now, here's the other thing I didn't mention. The solution to a system is an ordered pair. It's an x value and it's a y value. So right now in this problem, I have the x value. Great. I'm halfway done. Now I need y. Well, in order to find y, I'm going to substitute this negative 1 in for x into either equation. And if I want to solve for y, the best thing I could do is plug it into an equation that's already solved for y. Y is already by itself. And I have two options here. They're both set equal to y. I would get the same answer. So if I take this x equals negative 1 and I substitute it into, let's say, the first equation, y equals negative 2x, that would then become y equals negative 2 times negative 1. Negative 2 times negative 1 is positive 2. Look what would have happened if I plugged in a negative 1 in for x in the other equation, the second equation. Negative 1 plus 3 is 2. I get the same response. Final answer. Your solution is always the x value, comma, the y value. It's never the order you solve them in or anything like that, because I could solve for y first. It's always the x value, comma, the y value. So here my solution to the system is negative 1, 2. Awesome. Let's take a look at the next one. Y equals 3x plus 3 and x minus 3y equals 9. So in this system, I see that my first equation is already set equal to y. Y is by itself. So that means everything that I see is set equal to y is going to get plugged in for y into the other equation. So x minus 3y equals 9 becomes x minus 3, not y, times y anymore, but times the entire 3x plus 3, and then I bring down my equals 9. Now I simplify this out. So this would be x. I need to distribute that negative 3. Negative 3 times 3x is negative 9x. Negative 3 times 3 would give me negative 9. Bring down the equals 9. I see that I have an x minus 9x here. X minus 9x is negative 8x. Minus 9 equals 9. I see in this equation I have numbers on both sides, so I'm going to go ahead and get rid of this negative 9 by adding 9 on both sides, and if I do that, I would get negative 8x equals 18. Last step, because negative 8 and the x are side by side, which means to multiply, we divide both sides by negative 8, and our result is negative 2.25, or it could be negative 9/4. Now that I have what x is equal to, I want to solve for y. Now, I could plug this negative 2.25 into either equation for x, but I always tell my students, if you are looking to solve for y, use the equation that's already y equals. And so in this case, the first equation is the one that looks the best to me. Could I plug it into the second equation? Absolutely. But it's easier actually to use the one that's already y equals. So now if I substitute that in, this would look like y equals 3 times negative 2.25 plus 3. 3 times negative 2.25 is negative 6.75. and negative 6.75 plus 3 is negative 3.75. And so my solution to this system is negative 2.25, comma, negative 3.75. Next to 2x plus y equals negative 6. So if I look at this equation that's in standard form, the second equation, x equals 2y minus 1, I see that my second equation is my equation where the variable is already set solved for itself. So x is by itself. So x is equal to 2y minus 1. So that means where I see x in my other equation, I'm going to substitute in this 2y minus 1. So that means instead of writing 2 times x, I'm going to say it's 2 times 2y minus 1. Bring down the plus y equals 6. I'm now going to go ahead and just solve this multi-step equation. 2 times 2y is 4y. 2 times negative 1 is negative 2. Bring down the plus y equals 6. 4y plus y is 5y. I also added the 2 in that step also just to get rid of it at that point. So if I add 2 on both sides, that's how I get my 8. And if 5y equals 8, I would divide both sides by 5. I could have 8/5, or I could write it as 1.6. Once I know what y is, now I need to solve for x. I could plug this 1.6 in for y into either equation. But if I'm solving for x, the easiest equation to use is the one that's already x equals. So I'm going to grab that second equation, x equals 2y minus 1. I'm going to substitute in my 1.6 for y. So x equals 2 times 1.6 minus 1. 2 times 1.6 is 3.2, and 3.2 minus 1 is 2.2. Now remember what I said about your solution. Your solution is always your x value, comma, the y value. This is the first problem right now where we actually solve for y first. I don't want you to think that you put 1.6 first. No, it always goes in the order of the x value and then the y value. So 2.2 and then 1.6. Next one, let's take a look. Y equals 2/5 x plus 3. I see all of this is set equal to y. So all of that is going to get substituted in for y into the second equation. So this would be 2x minus 5, not times y, but times everything that y is equal to. 2/5 x plus 3 equals 10. So now I go ahead and I simplify this. So this would be 2x minus 5 times 2/5. The 5s would simplify out. I'm going to be left with a negative 2x. Negative 5 times 3 is negative 15 equals 10. What happens when you have 2x minus 2x? Those simplify out to 0. And I'm left with negative 15 equals 10. And I put the slash there because negative 15 does not equal 10. So what does that mean here for this system? If my variables are gone, I'm left with the numerical equation that doesn't make sense. It's not true. I always ask my students to think, is it a true statement or a false statement? This is definitely a false statement, which means there's absolutely no solution. These are not going to have an intersection. If I was to graph them, I hope you remember, that means that these lines would be parallel. Parallel lines would have no solution because they never intersect, and the solution to a system is where the lines intersect each other. Last two. Oh, you can see this one on the left is super easy. X equals negative 4 and y equals 5. This is the easiest system ever. Guess what the answer is? Negative 4, 5. There's nothing to substitute into the other equations. X equals negative 4 is a vertical line. Y equals 5 is a horizontal line. Guess where they intersect? Negative 4, 5. If you see equations like that, they are the easiest. Last one, 2x plus 3y equals 6 and y equals negative 3x minus 1. I see that my second equation is already set equal to y. So everything that's equal to y will get substituted in for y. So now this looks like 2x plus 3, not times y, but times negative 3x minus 1 equals 6. I go ahead and I do my distribution. So this is 2x, and then 3 times negative 3x is negative 9x. 3 times negative 1 is negative 3 equals 6. 2x minus 9x is negative 7x. Minus 3 equals 6. What do I have on both sides of my equation? Do I have numbers or variables? I have numbers. Which one do I get rid of? The negative 3 or the 6? It would be the negative 3. So we're going to go ahead and add 3 on both sides. And then negative 7 and x are side by side means multiply. I divide both sides by negative 7, and I get negative 9/7. Now I left it in fraction form because it'd be a very, very ugly decimal. Now that I know what x is equal to, negative 9/7, I'm going to go ahead and substitute that in if I need to solve for y. I told you guys the easiest equation to use is the one that's already y equals. So I'm going to take y equals negative 3x minus 1. I'm going to substitute in for x the negative 9/7, and then I'm going to simplify. Negative 3 times negative 9/7, well, remember, a negative times a negative is a positive. So that would be positive 27/7 minus 1. If I take 27/7 minus 1 and I replace the 1 with 7/7, 27/7 minus 7/7 is 27. And so my final solution for the system is negative 9/7 over and then 27. I hope this video was helpful. Thank you so much for watching. Bye.